Hello, good morning. Chemical properties of alkene. Alkenes are unsaturated hydrocarbons with the least one carbon-carbon double bond, which makes them highly reactive. The reactions of alkenes mainly occur at this double bond. Addition reaction of alkene. Alkenes undergo electrophilic addition reactions due to the presence of carbon-carbon double bond, which has highly electron density and can easily attract electrophiles, electron-loving species. Hydrogenation of alkene. Hydro means hydrogen, genation means addition. So hydrogenation is the addition of hydrogen across the carbon-carbon double bond of alkene, converting it into a saturated alkene. For example, the ethene is in the presence of nickel catalyst is converted into ethane. When alkene is treated with hydrogen in presence of catalyst nickel, platinum or palladium under pressure, corresponding alkene is formed. It is exothermic process because two sigma bonds form one pi bonds and one hydrogen sigma bonds are broken. Hydrogen sigma bonds are broken and pi bonds are formed. Addition of hydrogen halides, an alkene is converted by hydrochloric acid, hydrobromic acid, or hydrogen iodide into the corresponding alkyl halides. Mechanism step 1, ionization of hydrogen halides. First of all, hydrogen halides break down into cation and anion. The proton attacks the double bond to form the carbocation electrophilic addition. This is the alkene or double bond, electron density high. So this electrons attacks on this proton and forms in the positive charge and this carbon. Halide ions attack the carbocation. This negative charge attacks in this positive charge carbocation and forms alkyl halides. Markovnikov rule. In case of unsymmetrical alkenes, it states that when an unsymmetrical reagent adds to an unsymmetrical alkene, the positive part of reagent goes to that doubly bonded carbon atom, which bears the greater number of hydrogen atoms. See, in this example, in case of propene, addition of hydrogen halides, hydrogen bromides, the hydrogen positive parts adds to the portion which have the higher number of the hydrogen. So it forms and negative part, that is the halogen, adds to the lower number of hydrogen. It is the 2-degree type of equation, and this is the major product stable. But the negative parts goes to the higher number of the hydrogen, and the hydrogen goes to the lower numbers. It is the unstable. It is the Markovnikov's rule. Additional hydrogen in peroxide effects, anti-Markovnikov's rules. It's also called anti-Markovnikov's rules. The addition of hydrogen bromide to unsymmetrical alkenes in the presence of organic peroxides takes opposite to Markovnikov's addition of hydrogen bromide caused by the presence of peroxide is known as peroxide. In case of propene, addition of hydrogen bromide and the presence of peroxides, the hydrogen positive parts goes to addition, the lower number of hydrogen. That is the anti-Markovnik's rule, major product, and the bromine goes to the higher number of hydrogen. Just opposite, in the presence of peroxide, the bromine goes to the lower number of hydrogen, and hydrogen goes to the higher number of hydrogen is the minor product. Is the anti-Markovnik's rules, or this is the Markovnik's product is the major product. But in case of peroxide effects, it is the minor. Mechanism, it's the free radical reaction. Step 1, the peroxide is converted into alkoxy free radical. Step 2, the alkoxy free radical attacks the hydrogen, and the hydrogen and bromine have the covalent bonds and 2 electrons. Half electrons moves towards the hydrogen and half electrons to the bromide and produces bromide free radical. Step 2, the first case, the bromide free radical attacks on the carbon which have the lower number of hydrogen, and produces 2-degree free radical, more stable. And second steps, the bromide free radical attacks on the carbon which have the higher number of the hydrogen, and 1-degree free radicals, less stable, and attacks this carbon free radical on the hydrogen bromide and produces the 1-degree alkyl halides, propane halides. Addition of sulfuric acid, when Kong sulfuric acid added to the alkene, alkyl hydrogen sulfate is the form. The alkene, the sulfuric acid produces alkyl sulfuric acid. Mechanism, first of all, sulfuric acid breakdown into hydronium, water, and hydrosulfide ion, and trisulfonic acid, SO3. And this SO3 reacts with sulfuric acid and produces as SO3 sulfonic and hydrogen sulfate. This sulfonic parts is added to the carbon and produces alkyl hydrogen sulfate. Okay, this SSO3 attacks on this carbon. Okay. From the sulfuric acid, it produces HSO3. This is the positive charge, and this attacks on this double bond and positive charge on this carbon and neutralized by the hydronium and produces the alkyl hydrogen sulfate. Addition of water. Water adds to more reactive alkene in presence of acid to yield the alcohol. Mechanism, the alkene H plus this positive charge and attacks this water. Water have the lone pair of electrons, attacks on the positive charge, and loss of H plus and alcohol is produced. Addition of halogen in inert organic solvent like carbon tetrachloride add H to make the alkene to form the vicinal dihalides. Mechanism formation of halogenation and brominium ion. This double bond attacks on this bromine and bromide is removed. This bromium is produces. Attack nucleophile in antifusion, and this bromide attacks in carbon in antifusion. That is the opposite is bromide. Halohydrin formation. If the halogen of alkenes are carried out in the presence of water, the major products of the retention reaction in halo alcohol, which is commonly known as halogenation. This double bond attacks in this bromine and the bromide is removed. And this alcohol is produces and bromine and water. Mechanism formation of aluminum ions. Attack of nucleophile to the aluminum ion. The water attacks and the water molecules and removal of hydrogen ion and halohydrin is formed. Oxymercuration-demercuration. Alkene reacts with the mercuric acetate in presence of water to give the hydroxyl mercurial compounds, which on reduction is alcohol. Alkene reacts with the mercuric acetate, oxymercuration reaction, and demercuration in presence of sodium tetrahydroboron and produces alcohol. Mechanism step 1, dissociation of mercuric acetate. Attack of electrophile to the double bond. Sharing of carbocation. Attack of water molecule to positively charged carbon. And sodium tetrahydroboron is dissociated and BS4 minus produces. It attacks on this carbon and removes this part and forms the alcohol. Hydroboration oxidation. Alkene undergo hydroboration with diborane to yield the trialkyl borane, which produces alcohols on oxidation. Boric acid and ethyl alcohol. Mechanism. First of all, this diborane breakdown in BS3 attacks on this alkene, and this forms, bonds are forming, transition states, and mono and propyl borane is formed. Similarly, it forms tri and propyl bromine, and these peroxides is attacked by hydroxyl and hydrogen peroxides is formed. This hydrogen peroxide attacks on this tri propyl boron and forms and this alkyl groups attacks on this oxygen and remove the hydroxide. Borate esters it form. Similarly, triborate ester is formed and again attacked by the water and produces alcohol. Oxidation with potassium permanganate. When the alkene is treated with potassium permanganate, alkene is oxidized into 1,2-diol. Mechanism when the potassium permanganate break down in potassium plus MnO4, and this alkene in MnO4, KMnO4, and this transition state is formed. And this hydroxide attacks on this manganese and breakdown. Similarly, again, another hydroxide attacks in this manganese and produces two oxygen a negative charge and attacked by the two hydro proteum and forms the vicinal diol. For acid oxidation, it is the epoxide formation of double bond by treatment with for acids. The epoxide on hydrolysis produces 1,2-diol. Alkene, this is the for acids and forms these epoxides. Mechanism this the for acids and this the alkene attacks from the for acid this oxygen and this lone pair abstracts this hydrogen and the hydrogen oxygen this electrons moves toward this oxygen, and this oxygen have also lone pair of electrons. Also these electrons of hydrogen oxygen are abstracts this oxygen, so electron density high and attacks on this carbon, and this double bonds has also uh, electron density higher. So this electron density is also abstracted by this oxygen, and this oxygen have also the lone pair of electrons and moves towards this carbon bond. So this transition state is formed. And the epoxides is the produces when the epoxides is attacked by water, and this hydrogen is attached in this oxygen, and again this water hydroxide and attacks in this carbon and produces the vicinal diol. Ozonolysis, when the alkene reacts with the ozone in presence of inert solvent like carbon tetrachloride, produces ozonate compounds, which is treated with the zinc and water carbonyl compounds are formed. Alkene is treated with the ozone and in presence of carbon tetrachloride, it produces the ozonate compounds. In hydrolysis, in the presence of zinc, it produces the carbonyl compounds. Mechanism, when the alkenes is treated with the this ozone, and forms the unstable ozonate compounds. And the ozonate compounds have this the oxygen have lone pair of electrons. This electron can move here, and these electrons of the carbon and this oxygen have electron density high, so electrons moves toward this oxygen. And similarly, these bonds of electron toward this oxygen, and this is the unstable, and produces this the carbonyl compounds and this oxygen minus. And these carbonyl compounds again can attack this oxygen negative charge, this carbon, and this also have this double bonds and attacks this carbon, so forms these compounds. Also had that the carbon oxygen have the uh, oxygen in this carbon, and this oxygen, this electron attracts can move toward these bonds, and similarly the bonds moves toward here, and hydrolysis in presence of zinc and water and produces the carbonyl compounds. Polymerization of alkene, the process which the polymers are formed from their corresponding monomer is called polymerization, ethene to polyethene. Mechanism Ziegler Natta catalyst and aluminum 83 and titanium tetrachloride, titanium trichloride, ethene. This titanium Okay. Uh, this is the back end side. And so the Al3 attacks and one ET3 CS2 CS3 is added. And when this alkene is added and produces this pi complex, informs the carbon shift reaction, and this carbon is shifted toward this, and again back inside is created, and again this back inside another alkene can react as before like the here, and another pi complex is formed, and again the chain is the generating line landing, and the polymerization occurs. This reaction proceeds and so on. Okay, it's all about the chemical properties of alkene. And thanks for watching, and request you all like, comment, share, and subscribe. Thank you for patience. That's now. Bye bye. See you again.